You know that piece of gold jewelry you might have? Ever really looked at it? It feels solid, timeless. It's kind of normal, right? Well, the story of how it even got here, it's one of the most violent, most epic tales in the entire universe. Seriously. So let's dive into the secret life of this, well, alien metal.
So let's start this whole detective story with something you might even be wearing right now. We're going to zoom in on that familiar object, and we're going to ask a really simple question. But the answer? Oh, the answer is completely mind-blowing.
Okay, look at this. A simple gold ring. The thing is, geologically, physically, cosmically, it just shouldn't be here. It shouldn't exist on the surface of our planet at all. Think about it. The carbon and oxygen that make you, yeah, that stuff was cooked up inside a normal star. But gold? No way. Gold is a total cosmic outsider. Its very existence is a clue, pointing to a past so unbelievably violent it's hard to even wrap your head around.
So, you ready? Here's the first big reveal. That ring on your finger? It's not just metal. It's literally a piece of shrapnel from a dead star. You see, unlike the stuff that makes up our bodies, gold is just way too heavy to be forged in the normal life of a star like our sun. To make gold, well, the universe has to bring out the really heavy artillery.
Okay, so if a regular old star can't get the job done, where in the universe was this stuff made? To answer that, we have to go on a little trip. We're talking billions of years back in time, to a cosmic crime scene of almost unbelievable power. We're going to an event called a kilonova.
All right, a quick refresher on how stars work. They're basically giant cosmic forges, right? Giant fusion reactors. They spend their lives smashing lighter elements together to make heavier ones. So you get hydrogen turning into helium, helium into carbon, and on up the periodic table. But there's a wall, a hard limit, and that limit is iron. Once a star starts making iron, the party's over. For a star, iron is basically useless ash. It's the end of the line. It can't fuse iron into anything heavier. It's just done.
So to get something as ridiculously heavy as gold, you need something way more extreme than just a dying star. You need a kilonova. And what is that? It's what happens when two neutron stars, these are the collapsed, hyper-dense corpses of huge stars, get caught on a death spiral and just collide. Now, get this. We are talking about two objects. Each may be the size of a city, but each one weighs more than our entire sun. And they're smashing into each other. The violence is just unimaginable.
In that single catastrophic moment of collision, the surrounding space is just drenched in this insane storm of neutrons. There's a name for it, the R process, which stands for rapid process. And here's what happens. Any iron atoms just floating around get hit so hard and so fast by these neutrons, they're literally force-fed. They just soak them up, getting heavier and heavier, transforming past iron, past silver, until boom, they become gold and other heavy elements. And then all of this newly minted precious metal gets vomited out into space.
And the amount of gold we're talking about here, it's just staggering. A single one of these collisions, just one, can create and blast out an amount of pure gold equal to 10 times the mass of the entire Earth. Let that sink in. 10 Earths worth of gold. And this cosmic shrapnel, this debris, then just drift through the galaxy for millions, even billions of years, just waiting to get swept up in the next batch of new stars and planets.
Okay, so now we know where our alien gold comes from, right? A cosmic catastrophe. But that's really only half the story. Because the next big question is, how in the world did it get from the far reaches of the galaxy all the way to Earth and eventually onto your finger?
And this is where we hit the next big problem in our little detective story. See, when the Earth was just a baby, basically a big, hot, molten ball of rock, all the heavy stuff sank. And gold is extremely heavy and dense. So where did it go? Straight to the core. All of it. I mean, there's enough gold locked away in the Earth's core to coat the entire planet in the layer 4 meters thick. But it's totally, completely unreachable. So if all the original gold is at the core, why do we find any of it on the surface? Well, the answer literally came from the sky. Long after the Earth formed and its crust cooled down and got solid, our whole solar system went through this crazy phase called the late heavy bombardment. For millions of years, our planet was just pummeled by asteroids. And these asteroids, they were leftovers from the solar system's formation, and they were laced with all that gold from those ancient kilonovas. And because the Earth's crust was solid by then, this new shipment of gold didn't sink. It stayed right on top, like a light dusting. And here's the kicker. Every single piece of gold that humanity has ever mined came from that late-arriving alien coating.
All right, so we know where it's from, a star collision. We know how it got here,
a rain of asteroids. But what makes gold so special? I mean, why did basically every human culture on Earth independently become totally obsessed with this one specific metal? The answer is pretty cool, and it's all down to its unique and frankly bizarre chemistry and physics.
And I love this way of thinking about it, because it perfectly captures gold's personality, at an atomic level. See, most other elements are really reactive. They're constantly trying to hook up and bond with everything around them. But gold? Gold just wants to be left alone. It's the ultimate introvert of the periodic table. It's chemically bored.
And this comparison really shows you what that means in the real world. Iron, it just loves oxygen. It can't wait to combine with it and become rust. Silver reacts with sulfur in the air and turns that ugly black color. They literally self-destruct. But gold? Gold is what we call a noble metal. It just refuses to react with air, with water, with almost anything. You could find a gold coin in a shipwreck that's been on the ocean floor for 2,000 years, and it would look just as shiny as the day it was lost. You can see why ancient people thought this stuff was divine, right? It seemed immortal.
But okay, that explains why it lasts forever. But there's another mystery, one you've probably never even thought about. Think of all the metals. Iron? Grayish. Silver? Silvery gray. Aluminum? Gray. Platinum? Gray. Pretty much all of them are gray or white. So why is gold yellow? Why is it golden? The answer has nothing to do with chemistry. It's all about some very, very weird physics.
Okay, buckle up, because this is where things get really wild. A gold atom is so incredibly heavy, its nucleus is so massive, that its electrons have to whip around it at insane speeds just to keep from falling in. We're talking about half the speed of light, and when things move that fast, a funny thing happens. Einstein's special theory of relativity starts to take over. The physics literally warps. Those superfast electrons get heavier, their orbits change, and this whole warping effect makes the gold atom absorb blue light. So when normal white light hits the gold, the blue part gets soaked up. And what color do you get when you take blue out of white light? You get yellow. Gold is yellow because of Einstein's theory of relativity. How cool is that? So let's recap. We have this immortal, uniquely yellow metal, born in the collision of dead stars and delivered to us on asteroids. I mean, it's an amazing story, but it turns out all those bizarre properties logically pushed humanity toward one single conclusion. This stuff is absolutely perfect for money.
And it's not like we just stumbled on it by accident. It was basically a planet-wide process of elimination. I mean, think about it. You can't make money out of a gas, right? You can't carry it around. You can't use a metal that just rusts away into dust, or one that, bursts into flames when it gets wet, like sodium. And you definitely don't want your cash to be radioactive and kill you. So once you eliminate all the elements that are gassy or reactive or deadly, you're left with just a tiny handful of options.
And right in the middle of that small group of noble metals, gold was just perfect. It was in the Goldilocks zone. It's rare enough to be valuable. I mean, it's not common like iron, but it's also common enough that you can actually find it and make coins out of it. It's not impossibly rare like iridium. It was durable, you could divide it up, you could carry it around, and it had its own value. It was simply the most logical choice.
So let's just pull all of this together for a second. We've gone from the most violent explosions the universe can cook up to a shower of asteroids delivering it to our doorstep, all the way down to the bizarre rules of Einstein's relativity that give it its color. We've traced this absolutely incredible journey, all for this one single element.
And this, right here, is the thought I really want to leave you with. That simple gold ring, or that piece of jewelry, it is a direct physical link to one of the most powerful events the universe is capable of. You are literally wearing a tangible piece of cosmic history. So the next time you hold a piece of gold, remember what it really is. It's not just some shiny, pretty metal. It's the beautiful, immortal wreckage from a catastrophe of cosmic proportions.